And there are some additional materials that are out there that are not used as much and we didn't discuss in the book, but it is good to know about. The one on the left is cellular glass. So one of the brands is foam glass, and it is a 100% glass material that is manufactured primarily from sand, limestone, and soda ash. And if it's virgin materials, which come from two North American factories in Texas and Missouri, while up to 66% of recycled glass could be used and is used in Europe to create cellular glass. The ingredients are melted into a molten glass, which is cooled and crushed into a fine powder. The powdered glass is poured into molds and heated to below the melting point in a sintering process that causes the particles to adhere to one another. Next, a small amount of finely ground carbon black is added and the material is heated in a cellulization process. Here, the carbon reacts with oxygen, creating carbon dioxide, which creates the insulating bubbles. So carbon dioxide accounts for more than 99% of the gas in the cellular spaces. Pretty good material, and you'll notice from the shapes that we see here, it comes in board form, but it's also created to form insulation for pipes. So water pipes and ducts for heating work really well with this foam glass. The other that we see here is cork, and the advantage of cork is that it is a rapidly renewable material. There is nothing in the cork making process that is chemical, petrochemical. So the cork comes from cork trees, which are primarily grown in Portugal and Spain. The bark is harvested after the trees reach an age of around 18 to 25 years old, and it regenerates. So it's the portions of the bark are removed, and every 9 years the bark regenerates, and then it can be harvested again. Cork trees can live to be as old as 200 years, and 150 is kind of a typical average age for a cork tree. So that's a lot of cork that we can get from it. Now, the cork that we use for things like wine bottles is cut directly from cork as it comes off the tree, and it's very dense. It doesn't let any liquids come through. That's the main purpose, to create an airtight and liquid tight, fluid tight seal. However, there's a lot of pieces of cork that are left over from the making of corks that we use for stopping bottles, and that is ground up. And we see that ground up cork used for a number of things, such as Birkenstock soles, bulletin boards. There's cork on the underside of some floor materials that are out there. Cork can also be used for a floor, but when it's used for insulation, such as we see here, it's an expanded cork. The small nodules, the leftover recycled cork, and by the way, there are companies that will collect your corks from wine bottles and recycle them for you. These granules are used, but they're exposed to a superheated steam in large metal vats. The heating expands the cork granules and activates a natural binder that is in the cork called suberin that binds the particles together. So, comes from a tree. activated with hot steam, and that's the beauty of cork. Also, I'll say we see cork used not just for insulation, but in areas such as walls and, as I mentioned, underfloors, where acoustics are important, because cork is very good at deadening sound as well as being an insulator. This is aerogel, and I'll talk about it first, and then I'll read what it says at the top. So aerogels, which can get up to R10.3 per inch. We see on the left a very thick piece of aerogel. Typically with aerogel, we're going to see it in a very thin sheet because it is enormously expensive. Aerogel is a silica-based gel. So silica, remember, is the primary ingredient of glass, and it contains 99% trapped air with a very low density. It's fire resistant. Any of you who are bakers are probably aware of all the silica-based cooking things that have come into play. Silpat sheets for baking, for example, are made with silica. It also doesn't absorb any water, and the main way that we're using it is to stop the thermal bridging in houses and buildings. So putting a sheet of this on the exterior will create a thermal break, and it also, because it is a big mat, will stop air infiltration as well. It is enormously expensive, as I mentioned, so we don't see it used a lot. However, materials are changing all the time. We are constantly trying to find new materials that have a lower carbon footprint and a higher R value that will, it's sort of like when the alchemists were looking for gold. So keeping up on what's happening with insulation technology is something that you should do in your lifetimes as architectural designers, interior designers, and people in the building industry.